Hi everyone, I'm Verkerk, and this short video is just going to explain to you how to build a singularly polarized self-grounded bow tie antenna to be used on a dual-band Wi-Fi modem, typically operating between 2.4 and 2.5 or 5 and 6 gigahertz. The project is part of the high-frequency techniques course offered at the University of the Witwatersrand, but the design is simple enough for anyone to follow at home, so enjoy. Start off by cutting out a section of the conductive material you intend on making the antenna out of. As you can see here, I've gone with a steel bracket used to connect the downpipe of a gutter to the actual gutter, simply because that's what I had in my garage. You're welcome to use a paint tin or anything like that, something that you have lying around at home. Just keep in mind that metals such as aluminium are very difficult to solder. Next, draw the template you'll be using to cut out the antenna shape in your material. In this video, I'm making a bow tie antenna with a point angle of 90 degrees. Although difficult to see here, the long edge of this antenna is 140 mm and the short edge is 100 mm. To make the 90 degree angles at the point, simply measure 50 mm along the long edge of the antenna from the short edge and draw lines from these points to the center of the short edge. Do this on both sides of the antenna to construct the fold that gives this antenna its bow tie shape. You might have noticed a few dogs running around behind me. It's important to note that no animals were harmed during the filming of this movie. Additionally, in hindsight, it's probably a better idea to draw the template inside. Once you've constructed the template, cut it out and place it on the material you'll be using for the antenna. Trace around the template with a marker so that its shape can be cut accurately. Alternatively, you could just draw the shape directly onto the material without actually using the template. Once you have traced the shape of the antenna onto the material, you can begin cutting it out. To do this, I used a large metal guillotine. These might not be so easy to get your hands on, so making use of an angle grinder or even perhaps a hacksaw might have to do. Drill a hole in the center just large enough to fit the coaxial cable through. On the one tip, drill a hole just large enough to fit the inner insulation of the cable, and on the other tip, a hole just large enough to fit the inner conducting strands through. Feed the coaxial cable through the center hole. This cable was provided to me by the antenna design company Pointing. Strip off about 40 mm of the outer insulation, being careful not to nick any of the conducting braided strands underneath. Unbraid the strands, split them in half, and then twist each half together. This will make it easier to solder them back to the base at a later stage. Feed the inner insulation through the larger of the two holes at the tips of the bow tie. Press the newly twisted conducting wires against either side of the hole and solder them into place. When doing this, I found it easier to first apply solder to the base of the bow tie before pressing the conducting wires down and then simply heating the wires against the base to pull the solder over the wires like a blanket. Try to do this as fast as possible to prevent the heat of the plate from melting the inner insulation. If this happens and the inner conducting strands come into contact with the ground plate, the antenna will be ineffective. Fold that tip gently toward the center of the bow tie. I found that the sooner this is done after soldering, the easier it is because of the heat of the plate. Apply a small amount of tape around the cable between the ground plate and the newly made fold to isolate these two surfaces from each other. Skin off the inner insulation, trying to leave no more than 2 or 3 mm of insulation between the bottom fold and the inner conductor. Twist the inner conducting strands together. Bend the second tip toward the center and feed the inner conductor through the hole. Now remember, boys and girls, always ask a trusted adult to help you before handling any dangerous equipment. Finally, solder the inner conducting strands to the top side of the second fold. To prevent the bow tie from pulling more cable through the center hole, apply tape around the cable on the underside of the ground plate. If built correctly and dimensions followed accurately, the finished product should be able to work with any dual-band Wi-Fi modem operating between 2.4 and 2.5 GHz or 5 to 6 GHz. Here you can see me testing mine on a 2.4 GHz modem from 2.4 meters away. Notice the lack of yellow graph before attaching the antenna and in the size of that yellow signal strength graph after attaching it. So go out, give it a try, and thanks for watching.